Hi students, in this video we'll discuss about the working of an inverter, right? So it is a MOSFET or IGBT based single phase full bridge inverter connected to R load, right? This is the experiment. Now what do you mean by inverter? Inverter is nothing but which converts DC to AC, right? Almost everyone would have this device in your house or home, right? Which converts DC which is coming from a battery, it converts it into AC for our what to say our home domestic loads, right? You know what is an inverter now. Now to obtain AC voltage by using DC voltage from an IGBT based single phase full bridge inverter for different modulation techniques, this word you have to note, different modulation techniques, to measure the output voltage for different frequencies and duty cycles. So this is the name of the experiment. Like as we say inverter, there is something called PWM technique, right? Pulse width modulation technique. So there are different kinds of this PWM technique. So that is what we'll be discussing in this experiment or in this video. We'll see what are the apparatus required here. The apparatus required is single phase full bridge inverter module, right? And then we need a rheostat, we need CRO, and we need a multimeter, right? So these are the things what we require. Now, yeah, this is the tabular column. As I told you, there are so many kinds of pulse modulation, pulse width modulation. The first one is single pulse width modulation. The second one is multi pulse width modulation. The third one is trapezoidal modulation, and the fourth one is staircase modulation, right? So everything, if you see, the tabular column remains the same. So what is there here? Here the frequency is constant, but we are changing the duty cycle, right? Here the frequency is fixed, but here we are changing the duty cycle. Whereas here the duty cycle is fixed and the frequency is changing, right? So for one modulation, we'll have two tabular columns, one with constant frequency and the other one is with constant duty cycle, right? So same with everything, pulse width modulation, multi-pulse width modulation, and then we have trapezoidal modulation and staircase modulation, right? So these are some of the what to say some of the pulse width modulation which we'll be using. So now I'll tell you. So these are the different kinds of what to say modulations what we have. So this one is single pulse width modulation. As you can see, there are only one pulse for every half cycle, right? And this is multi-pulse. So multiple pulse means we'll have multiple pulses for both positive half cycle and negative half cycle. And the next one is the sine triangle modulation or trapezoidal modulation. So trapezoidal modulation, what is the difference between multi-pulse modulation and this one? You can see that the width of each pulse will be different. Width of each pulse will be different. So this will give you the sinusoidal effect. Sinusoidal effect in the output. So the RMS value will be close to sinusoidal like this, right? And this is staircase modulation. So what is the difference between this and this? Now here we had decreasing, increasing and again decreasing, right? But whereas here it is slowly, I mean initially it is in the decreasing order and slowly it will become at the increasing order, right? You can see the pulse width here. Starting it will be less and by ending it will be more. So this is when we compare a carrier wave with a staircase modulation, we get this kind of waveform. So how did we get these kind of waveforms? For a single pulse width modulation, when we consider, if you have something like this, right? And now this will be the zero line. And now if I compare a waveform like this, if I compare a waveform like this with this particular waveform, so what happens here is, now wherever the what to say this waveform is more, the triangular kind of waveform is more, there I'll get a pulse, right? So there I'll get a pulse. So this is one pulse. Now here it is more again, so I'll get a pulse here, right? And similarly for the other waveforms. So that is how we'll get this waveform. Now how to get the other one? Now the other one is with a constant pulse. For the constant pulse, this is how we'll be comparing. That is, we'll have a waveform like this. We can have n number of waveforms. and below also you'll have like this, right? Now this will be the zero line. Now what we'll be doing is we'll have one more wave which will be comparing, that is like this. Now if I have a waveform like this, now when I compare these two, wherever the triangular wave is more, there we'll get the pulses, right? So that is like this: 1, 2, 3, 4, 5, and downwards also 1, 2, 3, 4, and 5. So that is how you get the waveforms for multiple pulse, right? Similarly, how do you get for sinusoidal? That is the third one. That is when you have a sorry, the line is not proper. Yes. So consider a waveform like this. So if we have a sinusoidal waveform, right, and if I have the waveforms here like this to compare, this triangular waveform, so here if you have this kind of pattern, so wherever you can see here, it will be less in the beginning and again it will be more. So that when you compare, when you obtain the waveforms, you will get this kind of waveforms here, right? Again you have modified sine wave PWM also, which will have it in the theory but not in the lab, right? Similarly trapezoidal, how it will be, so we'll have a waveform like this, constant waveform, and we'll be comparing a sawtooth waveform like this. So that is when you'll get these kind of waveforms. I hope you have understood what is PWM now. We'll compare two waveforms and we'll obtain these resultant pulses which will be given to the switches of inverter, right? So as of now you have to remember this. Now we'll move on to the circuit. Yeah, I'll leave about the procedure. You can go through that by pausing the video. Now this is the circuit what we have for the inverter, right? So than this you'll understand in the next slide better. Yeah, this is the kit which we'll be using in the lab, and we need a CRO also, and we need a rheostat. So these are the things what we require. Now we'll see how the connections are done. Now you see here, this is the full bridge inverter which we'll be using for this experiment. This is a circuit which we'll be using. So there are four switches: 1, 2, 3, and 4. There are four switches. Similarly here also we have four switches: 1, 2, 3, and 4. There are four switches here, right? Now that is one thing, and we need a load. So that load is here, and we need a DC supply, and the DC supply is here, right? DC supply is here. Now we'll see how to do the connections. And there are four switches, right? 1, 2, 3, 4. There are four switches. So there are four sets of switching pulses for each switch. For each switch there will be two. One is positive and one is negative. That is for the pulses. So we have four switching pulses here, right? So now we'll see how to do the connections. Yes. So now what we'll do. Yes. Now here this is a supply. This is supply and this is a switch actually which is not. Yeah, this is a switch actually which is not visible properly. So now what we can do, we can directly give the supply to the switch and do the experiment. If you want the switch in the circuit, you can include this part. But since in the video it might be complicated to explain this, I'll directly connect the supply to the switches and then I'll explain the operation, right? So now what we'll do, yes, now see here there are 4 switches. First we'll connect the bridge, right? So here T1 and T3 is connected, right? T4 and T2 is connected. So I'll do this connection. So I'll connect one wire from here to here and another wire from here to here. So what are the connections we did now? This connection we have done. This connection we have done. Now we'll do this connection. So how to do that connection? So that is this one. This connection we have already done here. Now we'll do this connection now. These two connections. So if I want to do that, those two connections, so I'll connect it like this. Now a bridge is formed, right, with the 4 switches. Now how the the load is connected. Now one terminal of the load is connected here, and the other terminal of the load is connected here, correct? So here one connection and here the other connection. So here also you can see this load is connected between this and this one, correct? So we have connected the load also. Now we have to connect the supply. So how to connect the supply? This DC voltage source is connected like this. That is, positive is connected to T1 and negative is connected to T4 negative. So positive I'll connect it to T1 and negative I'll connect it to T4. Right, we have done that connection also now. Now we have to do the switching pulses. So switching pulses, I'll take green ink. Yes. So now this green one, this is for H1. So I'll connect it to H1, and this is H2. I'll connect it to H2. Right. And this is for H3, and this is for L1, and this is for L2. Right. So green to green. Now again the last connection, that is black to black. That is, now this one I'll connect it here, and this is for L1. So this one I'll connect it here, and this is H2. This will be connected here, and this L2 will be connected here. I hope you have understood the connections here. So now how to do the experiment? Now here we need CRO also. So this CRO will be connected across. The CRO will be connected across the load using the probe. To observe the waveforms. Now when we switch on the supply and give some voltage here, maybe like 30 volts, what it is shown here, right, 30 volts. Now this is the mode for changing various pulses, right? Increment, decrement, mode, everything will be present here. When you keep on pressing this mode, you will get all the waveforms. The first one was single pulse width modulation, multi pulse width, trapezoidal, and staircase, right? Once you set the type of PWM to single pulse width modulation, then you can change the duty cycle or frequency as we saw in the tabular column. And then what you have to do is you have to take the multimeter also, and you have to measure what is the voltage here for each case, keeping this in AC mode. So this is a multimeter where you have to connect a multimeter to this rheostat, and you have to note down the voltages, and you can see the patterns in this CRO. Right? So for various modes you have to repeat this experiment. So here you cannot write the values directly, so just know how to do this experiment. So in the lab you will be able to take the values. So for this it is very difficult to take the values by ourselves, by assuming we cannot do, right? So now here coming to this one, so for each pulse width modulation will have two types of tabular columns. One is for constant frequency and one is for constant duty cycle. So duty cycle you can adjust and write it here. Output voltage, these voltages are measured in CRO, right? These voltages are measured in CRO, and anyway these kind of pulses can be seen from the CRO. These kind of pulses can be seen in the CRO. So this experiment, the observation is done through CRO and the results are written. The results are written here through the multimeter, right? So this is how you do the inverter experiment. Now here you can see that. So here, how to understand this circuit? We have just seen how to do the connections. Now how to understand this circuit? I'll just explain the working of this circuit. What happens here in the positive half cycle? Now in the positive half cycle, this switch T1 and T2 will be on, right? So what happens to the, yeah, so positive half cycle, T1 will be on and T2 will be on. T1 and T2 will be on. So this will be the path for the current. This will be the path for the current. So now how the current is flowing through the resistor? It is in this direction. Correct. So this is the first mode of operation. Now in the second mode, what happens? In the second mode, what happens is T3 and T4 will be connected. So now here it will T3 and T4 will be working. So T3 resistor and T4. So now how is the direction of the current here? The direction of the current is in this direction. So positive half cycle it will be on the other one side and negative half cycle it will be on the other side. That is how this DC is getting converted to AC using this circuit. Right? So this is the working of inverter. I hope you have understood the connections, right? So doing the connections is very important here, and how you have to know how to set the mode here, right? By setting different mode you can get the different output voltages using the multimeter, and you can observe the patterns in CRO. So as of now you have to just know how to conduct this experiment, whereas readings you can automatically get it from the kit once you are able to perform the experiment, right? Thank you.